Hey guys, Vincent here, back with another video. In this video, I'll be showing you how to model temperature using a sinusoidal function, and some of the learning outcomes and what you'll learn at the end is how to create a sinusoidal model that models a real-life situation, solve real-life situations and word problems using a sinusoidal function, and being able to plug in numbers using the given data provided. So the word problem is, on a certain day, the temperature of Anglesville and Marksville can be modeled by a sinusoidal function. The maximum temperature in Anglesville is 92 degrees Celsius at 1306, and the minimum temperature is 58 degrees Fahrenheit at 106. The maximum temperature in Marksville is 85 degrees Celsius at 1257, and the minimum temperature is 63 degrees at 57. So I highlighted some of the most important points that we need to do, and let's go ahead and figure out the temperatures for Anglesville now. Okay, so what function models the temperature of Anglesville, where x is the time in hours from 00 and y is temperature in degrees Fahrenheit? First of all, we will convert minutes into decimals. So 1306, you guys can see this, would be converted, because this is in a 24-hour period, so it would be 13.1. Since it's 06 over 60 equals to 0.1. And the minimum temperature for 58 degrees is 0106. So this would be 1.1 as well, because it's 6 over 60, same thing, 0.1. So next of all, let's draw a graph, which would really help us. Here's y, x, and we have the two given points, which is 58 degrees Fahrenheit is the minimum, and 92 degrees is the maximum. So we need to go from here to here. And if we take out our calculators, we can do 92 plus 58 divided by 2, which is 72. And this gives us our amplitude. So here's Fahrenheit. And the x-axis is the time. So right here, from the given data, 13.1 would be the maximum, and 1.1 would be the minimum. So let's go ahead and draw our lines and plot our points. So, okay, now let's get on to the equation. So amplitude is 17. Our period is basically 2 pi over b. So since we have the period, it's actually 24 because it's in 24 hours. So it's equals to 2 pi over b. So we basically just multiply by b and divide by 24. So it would be 2 pi over 24. And this gives us pi over 12. So the phase shift, since it's going to the right, then we would get just 1.1. And in the equation, it would show up as minus 1.1, and the vertical translation, here, let me just write out the function really fast. And since this graph is a cosine, but it's reflected, we will just do negative cosine and our period would be pi over 12 x minus 1.1, which is a phase shift, and plus 75, which is the height of our equation. 72 is also the starting point. So now let's head on over to Marksville. Okay, so Marksville gives us the same equation. So let's get right ahead and convert from temperature into decimals. So the maximum temperature of Marksville is 85 degrees Fahrenheit at 1257, and we can go ahead and convert that to 12.95 because it's from minutes into decimals. So 57 over 60 equals to 0.95. Now we see that minimum temperature of Marksville is 63 degrees Fahrenheit at 0057. So this means that it's 57 over 60 equals to 0.95. Okay, so let's go ahead and draw a graph. So we have the y as the temperature in Fahrenheit, and the x as the time. So let's mark our points. The minimum time is 0.95. The max is 12.95. And the minimum temperature is 60 degrees Fahrenheit. Max is 85. And we could do 85 plus 63 divided by 2, which gives us 74. And from 63 to 74, that's 11, so that gives us our amplitude, and from 85 to 74, it's still 11. That's our amplitude, and let's go ahead and connect our dots. So this is 11, and our phase shift is from 0 to 0.95, so that's 0.95. PS 0.95. Our period is just the same thing as the last one. It's over it equals to a 24-hour period, so 2 pi over b equals 24, and that would give us pi over 12. Our vertical translation is from 0 to 74. Basically, vertical translation is the height and where we start, the starting point. So that's 74. And let's go ahead and write our equation. So we have a reflection, cosine reflection, because it's starting from here instead of here. And 11, that's our amplitude. And pi over 12, that's our period. 0.6 is our phase shift. And 74 is our starting point. Okay. So in our next problem, it wants to find what times are the temperatures in Anglesville and Marksville both equal to each other. And so let's write out our equations first. So let's write out the Anglesville equation. Negative 17 cosine pi over 12 x minus 1.1 plus 75. And Marksville is negative 11 cosine pi over 12 x minus 0.95 plus 74. So we will set this to y1 and this to y2. So after you type this out, it should look like this. Okay, so now go ahead and intersect your functions. You just hit second trace or second calc, and then hit number 5, intersect. And once you do that, there's going to be a similar point. So it's going to somewhat look like this, and this would probably be the minimum. So your maximum temperature would be 73.387 degrees Fahrenheit at 6.73, and this would be in decimals currently. And your minimum would be 70.983 degrees Fahrenheit at 20.0167. And the only thing that you need to do is to convert from decimals to minutes now, since we're going to give the time. So from 6.73, you would do multiply by 60 to get 0644, because this would be in the 24-hour period, and when you multiply 7.73 by 60, you would get 44. And then for the minimum, you would do same thing, 20.016 times 60. This would give you 2001. Okay, yeah, so we figured out the times for the maximum temperature and for the minimum temperature. So, yeah, see you guys later. Thank you for watching. See ya!